Live audience, sir.
Another sir, Mantri. Yes.
Good afternoon, everyone.
Today, discuss about the biomolecules.
Okay. Actually, from this chapter, some topics are deleted, except deleted chapter. We'll discuss some important one. Now we'll start the biomolecules. Okay, right. Now see, biomolecules. First one, we'll discuss about the carbohydrates. Carbohydrates. So generally, what are the carbohydrates? Okay, polyhydroxyaldehydes and ketones are said to be carbohydrates. What is the difference? Polyhydroxyaldehydes and ketones are said to be polyhydroxyaldehydes and ketones are said to be carbohydrates. Polyhydroxyaldehydes and ketones are said to be carbohydrates. For example, if you want to take one example, the glucose formula, glucose C6H12O6. Sir, any general formula is not there, sir, for carbohydrates. Is there any general formula? So, if you want to write the general formula, CH2O taken by. This general formula we are going to write. But whatever the formulas are, it will be fit in this one. Whatever the formula, molecular formula of carbohydrates fit in this one, we are unable to say those all are carbohydrates. For example, you see, I am telling you, this is the glucose. This is the glucose. This glucose is fit into this formula. What is the check? C6H2O taken 6. Yes, it's fit. XY. Carbon C6H2, 2 into 6, 12, and 6 oxygen. 12 and it's fit. Okay. So, this is also carbohydrates. Means some molecules formula can fit into this formula, sometimes cannot fit. So whatever the formulas are, molecular formulas are fitting into the formula, we can't say all are carbohydrates. One example, see, I'm going to give another one example. This is the acetic acid. Oh, what is this? Acetic acid or ethanoic acid. Now see what is the molecular formula? C2H4O6. Oh, sorry, O2. This is fit in this formula. C2H2O taken 2. It is going to fit. It is going to fit in this formula. C2H2O taken 2. X and Y. X 2 Y. C2H2O taken 2. But if this comes under carbohydrates, no. Means what I am telling you now. Whatever the formulas are, molecular formulas are, can fit into this formula. We can't say all are. We can't say these are carbohydrates. We can't say. Okay. Some carbohydrates also does not fit into this formula. Some carbohydrates also does not fit into this formula. For example, see rhamnose. This is a rhamnose. Okay. In this rhamnose formula, what is it? You know, from glucose to oxygen is less. C6H12O5. This is a rhamnose formula. This is also one type of carbohydrate. Carbohydrate. Okay, but this rhamnose formula does not fit into this formula. But this is carbohydrate only. Rhamnose is carbohydrate only. Rhamnose is carbohydrate only. Okay, but not fitting into this formula. But we cannot say this is not carbohydrate. Yes, carbohydrate. So you remember, general formula is not there means is there. But all are fit, all are not carbohydrates. If which are the following not fit, those are not a carbohydrates. We can't say like that. Okay, that you remember. Then what is the carbohydrates? Polyhydroxyalkanes and ketones are said to be carbohydrates. You remember. And see, this important point here, I want to say, these carbohydrates, so they are classified into three types. What is that? These carbohydrates, they are classified into how many types? Three types. Classification of carbohydrates. Classification of carbohydrates. Classification of carbohydrates. In the classification of carbohydrates, these are classified into three types. First one, monosaccharides. Second one, oligosaccharides. Third one, polysaccharides. Monosaccharides, oligosaccharides, and polysaccharides. So one information I want to give. Sir, what are monosaccharides? The saccharides cannot further undergo any hydrolysis. What are monosaccharides? Furtherly, what is it? Furtherly cannot undergoes hydrolysis. Furtherly cannot undergoes hydrolysis. Those are said to be monosaccharides. Okay. Naturally occurring monosaccharides. See, naturally occurring monosaccharides, 20 monosaccharides are there. Naturally occurring monosaccharides. How many are there? 20 are. Those all are not undergoes furtherly hydrolysis. So, for example, if you want to example, sir, give examples for. Sir, monosaccharides ke what are the examples are there? You know, glucose, fructose, and ribose. Glucose, fructose, ribose. These are the best example for the what is it? Monosaccharides. Okay, this is the information about the monosaccharides. Okay. So now see, we'll discuss about the oligosaccharides. So what are oligosaccharides? Second one, we are going to discuss about what is it? Oligosaccharides. These are the saccharides undergoes hydrolysis. Undergoes what is it? Undergoes hydrolysis. These are the saccharide undergoes hydrolysis. Then give 2 to 10 monosaccharide units. How many? Then give 2 to 10 monosaccharide units. 2 to 10 monosaccharide units. Okay. Actually, 2 to 10 monosaccharide means these are furtherly classified. Disaccharide, trisaccharide, tetrasaccharides, like that they are classified. Oligosaccharide. If it is undergoes hydrolysis, gives 2 to 10 monosaccharide units. Okay. So, for example, sir, you know that sucrose. I'm taking the example. Sir. This is a sucrose. You know, sucrose is a composite of 2 monosaccharides. What are those? Really, sucrose undergoes hydrolysis due to 2 monosaccharides. What are those? You know, glucose and fructose. What is it? Glucose and fructose. See, next one, maltose. I'm writing these are disaccharides. And we have lactose. This is a lactose. Maltose. Maltose is undergoes hydrolysis then you 2 moles of glucose. 2 moles of glucose. Lactose undergoes hydrolysis. What is it you know? Lactose. Ribose plus glucose. Use what is that you know? Ribose and glucose. Glucose. Galactose, not glucose, galactose. Ribose. Galactose. Glucose and galactose, beta D galactose. Beta D glucose. Okay, so these are the what are these? Sucrose, maltose, lactose, disaccharides. So these are all comes under oligosaccharides because these are undergoes hydrolysis then you 2 to 10 monosaccharides. Okay, right. Now we discuss about the polysaccharides. Now we discuss about the polysaccharides. Polysaccharides. What are polysaccharides, sir? These are further undergoes hydrolysis, give large number of monosaccharide units. What is that? Furtherly undergoes hydrolysis and gives large number of monosaccharides. Large number. Large number of what is this? Monosaccharide units. Large number of monosaccharides. Okay. Right. So these are polysaccharides. If you want to the example, for polysaccharides, you can say starch, cellulose, and glycogen. You know, glycogen is called animal sugar. Yes, glycogen is also the best example for polysaccharide. Glycogen. It's an animal sugar. Animal sugar. Yes. Okay. Stored in muscles. Okay. And that camel hump also stored some amount of glucose. That is in the form of glycogen. It's a polysaccharide. Whenever the body required energy, the glycogen undergoes hydrolysis converted to the glucose. Then give the energy. So these are some best examples of the polysaccharides. Polysaccharide means these are the saccharide undergoes hydrolysis then give large number of monosaccharide units. Okay. And you know the important thing is that these polysaccharides are sweetless. No sweet in taste. No sweet in taste. Polysaccharides are no sweet in taste. Why? Because These are sugars to non-sugars, so they are classified like that. These are called sugars. Sugars. Sugar and non-sugar. Sugar containing majorly all monosaccharides, you know that, which is present in honey, ripened fruits. Sugar containing fruits are present, you know that. Example: glucose, sucrose, fructose. So these are the best examples for the sweet containing sugars. So fructose is highly sweetest containing substances. You remember, highest sweet containing substance is fructose, which is present in honey. Honey. In non-sugars, you know that. Yes, what is polysaccharides? Starch. So what is starch? Rice flour powder added to the water and boil, then one type of liquid substance is formed. That is called starch. Yes, this is sweetless. Okay, these are comes under non-sugars. Cellulose also non-sugar. Cellulose. This is also non-sugar. It's not having taste. No sweetness. It's not having taste. Sweet. Okay, these are the sugars and non-sugars. Right? So then we'll discuss about the monosaccharides. What is this? We'll discuss about the monosaccharides. We'll discuss about the monosaccharides. Right. Camera is going to blur something. Okay. Right. So what are monosaccharides? Already I told you. These are further in non-amorphous hydrolysis. See, this monosaccharides is also classified into two types generally here: aldoses and ketoses. What is that? You know, aldoses and ketoses. Aldoses, second one ketoses. See, in the carbohydrates having the aldehyde functional group, that is aldoses. Aldoses contain, what is it? Contain aldehyde functional group. So aldehyde functional group contain carbohydrates. What is the example? Say glucose. Example, what is that? Glucose. Ketones contain ketone functional group. Ketone functional group. Okay. So best example, sir, what is this? This is fructose. Fructose, it has ketone functional group. Fructose, it has ketone functional group. Okay. So aldoses and ketoses, they are classified. So these monosaccharides only depend upon functional group only. There is no other classification. Yes, it's there. Other classification also is there. Those are classified reducing and non-reducing sugar. What is it? Reducing and non-reducing sugar. See. Reducing sugars and non-reducing sugars. Reducing sugars and non-reducing sugars. So what are the reducing sugars? What is reducing? What are reducing? Simple. I want to say one point. whatever the carbohydrates reduce the whatever the carbohydrates, what I'm telling, whatever the carbohydrates reduce the two reagents. One is tolerance reagent, another one failing reagent. Tolerance reagent and failing reagent. Whatever the carbohydrates are, reduce the tolerance reagent as well as failing reagent. Those are said to be reducing sugars. Okay. So whatever the carbohydrates not reduce. Sir, examples, sir. Example for reducing sugars. Examples. So examples you remember. Example for reducing sugars. Example for reducing sugars. What are those? What are those? Glucose. Maltose, lactose, maltose, lactose. These are examples. So non-reducing sugars means non-reducing sugars. Means those are the sugars. These are sugars. Non-reducing sugars means those are the sugar cannot reduce it. Cannot reduce. What is it? Tolerance reagent. Tolerance reagent as well as failing reagent. Cannot reduce. Cannot. So these are non-reducing sugars. Okay? Right. And the next you see, what's an example, sir? So example only for non-reducing sugars you remember, that is sucrose. Where is present sucrose? Table sugar. Normally we can use in kitchen. That is sucrose. Okay? Then we discuss about the glucose. Sir, what is the glucose? Okay. Now we discuss about what is the glucose. See, in that glucose, formula C6H12O6, which has aldehyde functional group. Which has aldehyde functional group. Okay. Which is called actually aldohexoses. Glucose is called what is it? Aldohexoses. Or called, this is also called dextroses. Dextroses. See, aldohexoses come out dextrohexoses. Dextrose. Nothing but D-glucose. TV advertisement it will be coming out. Glucan D. Dextroses. That is advertisement. Okay? Right. Now see, glucose formula C6H12O6. So glucose, these are the monosaccharide classification on the basis of number of carbons, what type of functional groups, also they are classified. This glucose has what is a functional group? How many carbons are there? Yes. How many alkyl groups are there? Yes, everything we can discuss about the glucose. So there is a concept is that structure elucidation of glucose. What is this? Structure elucidation of glucose. Structure elucidation of glucose. Elucidation means what is the structure? Determination. Elucidation of the glucose. Okay. Now see here, structure elucidation of glucose. Now what I'm telling, glucose has how many carbon? How can you confirm that? See. For example, first one see, I'm taking the glucose CHO, CH2OH taken 4, CH2OH. This is the glucose. Okay. This glucose is a reaction with HI and heat. HI and heat. What happens? You know, HI is a very powerful reduction reagent. Very powerful reduction reagent. So what is the function of HI? HI in the presence of heat, or sometimes we can write as a red phosphorus. What is the function? If you know the function of this HI, then you can apply the same application of the glucose, then you understand what is the concept. Then that's why you ask. You ask now what is the application, what is the function of HI in the presence of red phosphorus? What you will do? Sir, all alcohols. What is it? All alcohols. Aldehydes. Ketones. Then, and even carboxylic acids also. Carboxylic acids also converted into the, what is it? Converted into the alkanes, and this is my function. What is the reagent function? HI in the presence of. Sorry, okay, I am taking ethyl alcohol, I am taking ethanol, I am taking acetone, I am taking ethanoic acid. These all I have taken. All I have taken. Okay. So these are reactions with HI in the presence of heat or red phosphorus. What is the answer? All are undergoes reduction. Then what is the answer? Here how many carbons are there? 2 carbon, ethane, CH3 plus. So I am giving the moles also. How many moles are here? 2 HI mole. Here 4 HI mole. Here also 4 HI mole. Here 6 HI is involved. 6 HI. So then 1 moles of water molecule beside. Here also how many carbon? 2 carbon. So here also answer is a ethane. CH3 plus H2O plus I2. Here also same propane. Here ethane. There are how many I2? 2 I2. 2 moles of water plus 6 I2. 3 I2. Okay. So this is the function of HI in the presence of red phosphorus. So you know that glucose structure actually, really glucose structure, you know. I'm writing it. C double bond OH, CH2OH, 1, 2, 3, 4. OH, OH, H, OH, H, OH, H, H. This is the glucose structure. It has really one carbonyl group on the head. These all are alcohols. So these all are coming to the aldehydes. What is aldehyde alcohols? All are coming to the elements alkanes. So generally you see this glucose has how many carbon? 6 carbon. So remaining all aldehydes and alcohols are under reduction, then formation of the answer, you know. N-hexane. What is the answer, you know? N-hexane. CH3, CH2, 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 CH3. 1, 2, 3, 4, 5, 6. So the answer is N-hexane. So by this reaction, we can confirm that. What do you understand by this reaction? Glucose reaction with HI and heat. Then what is the confirmed? What is confirmed? So it means that glucose has 6 carbons. What is it? Glucose has 6 carbons. Glucose has 6 carbons. 6 carbon. This is a compound here by this reaction. Okay, right. And the next you see, next you see, glucose has how many carbon? 6. The second one is that C double bond OH, CH2OH taken for CS2OH. What is this? This is glucose only. Okay, this glucose is reaction with the HCN. This glucose is reaction with the HCN. Okay, so then here what happened? Already you know that. Already in aldehyde ketone chapter we discussed it. Aldehydes are reaction with the HCN. HC double bond O, CH3C double bond H. Reaction with HCN. Nucleophilic addition reaction takes place. H plus Cn minus, the Cn minus is attracted to carbon carbon, then the bond should be here. Then what is the answer? CH3CO minus, downside CnH. Remember this proton is attracted to O minus, then formation of CH3OH, HCN. What is this synonym? Aldehydes are reaction with the HCN, undergoes nucleophilic addition reaction. Then formation of this is called cyanohydrin. Cyanohydrin. Okay. So by this reaction, what we are confirmed that given reactant is having the carbonyl carbon. Carbonyl carbon. Carbon to oxygen double bond group is a that is carbonyl. Now let us check. This really is going to reaction with HCl towards the glucose. If the product it will be formed HC, OH, Cn, CHOH, taken for CH2OH. So what is this? Glucosinohydrin will be formed. Glucosinohydrin. This reaction, what is confirmed, sir? What is confirmed this reaction? Sir, glucose has carbonyl functional group, sir. What is it? The glucose has carbonyl functional group, sir. Glucose has carbonyl functional group, sir. We can confirm that. Yes, sir, I'm unable to believe. You can show any other reaction for this glucose has carbonyl functional group? Yes, is there. What is that, The same glucose OH, H, OH. Now see here. This is also glucose. Okay? Which is reaction with H2NOH. You know what is H2NOH? What is it? What is this, OH hydroxyl NH2 amine. Hydroxyl NH2 amine. NH2 amine OH hydroxyl. Hydroxylamine, this is a hydroxylamine. This hydroxylamine glucose reaction to glucose, glucoxime it will be formed. Glucoxime. What it will be formed, Glucoxime it will be. If you want to see answer is there, C double bond N, OH, H, CH2OH to taken 4 and CH2OH. To write this is the product. What is the product name? Glucoxime. This product is coming means given aldehyde, given glucose has, what is it? Carbonyl functional group is present. What is present? Carbonyl functional group is present. So carbonyl group functional group is present. We can confirm by two reagents. One is a hydrogen cyanide. One is hydroxylamine. OHO hydroxylo NH2 amine. Hydroxylamine. Okay, right. So glucose has carbonyl functional group. Then what is that carbonyl functional group? Carbonyl functional group, seven carbonyl functional groups are. Aldehyde, ketone, carboxylic acid, esters, acetylhalides, anhydrides, amides. What is that carbonyl? Yes, there is aldehyde, ketone, discuss. Okay. Right. See now. See now, here I am going to take aldehydes reaction with aldehyde. This is glucose. Glucose reaction with Br2 plus H2O. Br2 plus H2O. This is mild oxidizing agent. Mild oxidizing agent. Mild oxidizing agent that is. Really, what is confirmed? Previous reaction. Glucose contain carbonyl function. What is it? Aldehyde ketone. We can confirm that. If really, that is, if aldehyde is there, that is easily undergoes oxidation by the mild oxidizing agent. If ketone is there, not undergoes oxidation. So really, it is a mild oxidizing agent, which is really undergoes oxidation. Then what do we confirm that? What we confirm? Aldehyde group is confirmed. So now really, COOH, CH2OH to take 4 and CH2OH. What is found in gluconic acid found? What is it? Gluconic acid. Gluconic acid. Yes. By this gluconic acid, we can confirm that. We can confirm aldehyde group present in where? By this reaction, what is it? By this reaction, aldehyde functional group present in glucose. Aldehyde. Functional group is where? Present in glucose. So this is the information. Okay, right. Okay, sir. So glucose has 6 carbon. Glucose has carbonyl group. Glucose has that carbonyl group is aldehyde. Sir, you told that carbohydrates mean polyhydroxy aldehydes and ketones. Mean alkyl group also present, sir? Yes. Alkyl groups also present. How many alkyl groups are there? How can we confirm? See the reactions. Let's do it. Now see. What I'm going to tell? How many alkyl groups are there? You know that for general reaction, Really, alcohols reaction with acetic anhydride. C has 3, C double bond O, C double bond O, C has 3. What is this? This is acetic anhydride. Acetic anhydride. This is acetic anhydride. Acetic anhydride reaction with the alcohols. See, I'm making a bond here. So these hydrogen is attached here. So then what is the form? C double bond of CS is joined to the oxygen. C has 3 CH2. Go C double bond of CS3 plus. Then remain what is it? C has 3 C double bond OH. Yes, just it will be found. Yes, just. What is it? Yes, ethyl ethanoate is found. Ethyl ethanoate it will be. What are these ethyl ethanoates? These are the esters. These are the esters. Esters are it. So it means that, what is the meaning? If really glucose has alcohol functional group, there also ester forms, na? Yes, forms. See. Now I am going to take CHO, CHOH taken 4, and CH2OH. Yes, sir, it is appearing some alcohol groups. So here I am taking 5 moles of acetic anhydride. CH3 C double bond O taken 2 4. This is the 5 moles of acetic anhydride is required. If you want to get any confusion with a written structure like this, you take like this. C has 3 C double bond O, C double bond O, C has 3. The 5 moles. Okay now? Right. So these anhydrides are reaction with the glucose, or it will be from esters. Glucopentaacetate, acetates, it will be from. Esters are called, ester suffix name 8. 8. Ester suffix name 8. A2. That's not the one. Right. So answer is that CHO, C double bond O, C has 3. CH2O, C double bond O, C has 3. They are taken 4. This form. What is glucose pentaacetate? Glucopentaacetate. Pentaacetate. Glucopentaacetate will be formed plus 5 moles of acetic acid. So by this reaction, what you are confirmed? Sir, by this reaction I confirmed that glucose has 5 alcohol groups. By this reaction I confirmed that. By this reaction, I confirmed that glucose has 5 alcohol groups, 5 alcohol groups. I confirm this. Okay, I mean, explain. Okay, right. So, okay, I understood, sir. Glucose have 5 alcohol. All are primary, na? All are secondary, na? All are tertiary, na? What type of alcohol present, sir? That is also important, na? Yes. Now, sir. How can you confirm? See, hello, my dear students, listen here. Primary alcohols undergoes oxidation very quickly than compared to secondary and tertiary. Yes. Now see here, This is aldehyde. Reaction with HNO3, concentrated HNO3. Concentrated HNO3. See, this is oxidizing agent. You know that these are the 4 R's secondary alcohols are there. This is one primary alcohol. Secondary alcohol not oxidized by the concentrated HNO3. Only primary alcohol and oxidation, including aldehyde also. So their function C, COOH, CHOH taken 4, and COOH. This is called, the name is a very, very important. The last question is that glucose when going to reaction with the concentrated HNO3. What is the answer? Answer is that Saccaric acid. What is this? Saccaric acid. This is yes, it's not a question. Yes, Saccaric acid. Okay? Right. Important. That's why I written like this. Why I written like this? It's important. They ask for competitive level tomorrow. The reason you can identify, oh, glucose is reaction with the concentration with the saccaric acid. Yes, saccaric acid. Yes. Can recognize it. That's why I written like this. Okay. So, by this reaction, what you are confirmed by this reaction? I confirm that glucose has, tell me, glucose has one primary alcohol and 4 secondary alcohols are present, sir. So these are the structural elucidation of glucose. By this all reactions are we are confirmed that first reaction, glucose has 6 carbon. Second reaction, glucose has 1 carbon and functional group. Third reaction, glucose has 1 aldehyde functional group. Fourth reaction, glucose has a 5 alcohol functional group. Fifth reaction, glucose has 1 primary alcohol, 4 secondary alcohols present. Okay, these are the reactions, structural elucidation of the glucose. We'll discuss tomorrow. Okay, thank you. Bye bye.